Okay, so right now I'm going to be looking at the, I know it says Unit 2 review. This should be Unit 3 review. And this is Part 1, complete the square. So steps to solve an equation by completing the square. First of all, we need to know what is b divided by 2, and this is for an equation set up where we have x squared plus bx is equal to anything. We also need to know what b divided by 2 squared is. Once we have that, we will always add that value, the b divided by 2 squared part, to both sides of the equations. On the last video, we discussed factoring, but what we need to do is we need to factor the left side of the equation. Due to the process called complete the square, it will always factor to x plus whatever b was divided by 2 squared, which is why we look for b divided by 2 in the first step. Our final step is we would solve the equation for x. So our equation that we have here is x squared plus 2x is equal to 48. So the first thing that we need to do is we recognize that it's set up in the format. So what we're going to do is we're going to take our b value, in this case the 2, and we're going to divide it by 2. And we can see that 2 divided by 2 would be 1. Step 2, I need to square that result. Would also be 1. What that's going to tell me to do is I'm going to put a plus 1 on each side of the equation. It's always plus 1. So even if the calculator says a negative, we need to put a plus. So when we do that, we're left with x squared plus 2x plus 1 is equal to 48 plus 1, or 49. Now we need to take x squared plus 2x plus 1 and factor that side of the equation. So it will factor to x plus whatever the b value was at the very beginning divided by 2. So 2 divided by 2 we said was 1. So x plus 1 squared equals 49. Now we need to solve the equation for x. So the next thing that I would do is to undo the square. I would take a square root on each side. That will leave me with x plus 1 is equal to either a positive or a negative 7. To isolate x, I would now subtract 1 on each side of the equation, leaving me with x is equal to a positive or negative 7 minus 1. Now these are integers, so I can easily break these down, where I'd have positive 7 minus 1, negative 7 minus 1. 7 minus 1 would be 6, negative 7 minus 1 would be negative 8. And those would be my solutions to this problem. The main reason why complete the square is very useful is for irrational answers. And typically we want it to be set up where it is a constant in front, where it's just a plain x squared, and values that we otherwise cannot factor to solve. If you are left with a square root that cannot, or that does not turn out to be or that is not a perfect square. So this one we had 49 and it was a perfect square reduced to 7. What you want to do is you want to reduce the square root as much as you possibly can, and then you want to keep it as a square root in your final answer. So say we had the following example. This was one on the assignment, where if we had x squared plus 4x equals 20. So I'm going to continue by doing complete the square. So I recognize my b value here would be 4. So I have 4 divided by 2 would be 2. I know I need to square the result, so 2 squared would be 4. So I need to put positive 4 on each side of the equation. After I've done that, I'm left with x squared plus 4x plus 4 is equal to 20 plus 4, or 24. I now need to factor the left side of the equation, which we said was going to factor to x, and then b divided by 2, so 4 divided by 2 would be 2. X plus 2 squared is equal to 24. So this time when I solve for x, I square root each side, But square root of 24 is an irrational value. It does not turn out evenly. It will still receive the plus or minus in front. But what I need to do is I need to simplify my square root of 24. So square root of 24, I would choose two factors, and I would choose 4 and 6 here. 4 breaks down to 2 and 2. 6 would break down to 2 and 3. So remember, if we have a pair of a value, it needs to be placed in front of the radical. If we have a single value, it would be placed underneath the radical. I see I have a pair of 2's, but I have a single 2 left, and I have a single 3 left. So my simplified form would be 2 square root of 6. So I have positive or negative 2 square root of 6. I still need to isolate the x, so I would now subtract 2 on each side. And so we have a negative 2 plus or minus 2 square root of 6 would be our answer. Final example of complete the square would be question number 4 from the assignment, where we have x squared plus 4x plus 10 is equal to 0. So an equation that otherwise would be impossible to solve by factoring, because the only factors of 10 would be 1 and 10, 2 and 5, and no factors of that will add up to 4. So the first thing I need to do is I need to make it fit the format. So I would subtract 10 on each side of the equation. When I do that, it would leave me with x squared plus 4x is equal to negative 10. I would complete the square the exact same way as the previous problem. This one's very easy because it has the exact same b term as the last problem. So I've got 4 divided by 2 would be 2. I would square the result, which leaves me with 4 again. So I would put plus 4 plus 4. So I'm left with x squared plus 4x plus 4 is equal to negative 10 plus 4, or negative 6. So I'd factor the left side, x squared plus 4x plus 4. We've already used this one before, so it would be factored to x plus 2 is equal to negative 6. Now to isolate my x, I would take a square root on both sides, but there's not a real solution of the square root of negative 6. So the negative becomes a letter, it becomes an I for the imaginary. And we need to try to break down the square root of 6, the same as previously. 6 only breaks down to 2 and 3 though for factors, and I will have no pairs, which means both are single, both will stay under the square root. So I'm left with x plus 2 is equal to I times the square root of 6, and the I again came from removing the negative. So to isolate the x, I would now subtract 2 on each side of the equation, leaving me with x is equal to negative 2 plus or minus the I square root of 6, which would be my solution. Okay, transforming to vertex form. So to transform an equation into vertex form, we would start by following steps 1 through 4 of complete the square. So this would be an equation that would be similar to something like y is equal to x squared plus 6x minus 16. So the first thing, I don't really need the y, I don't really need f of x, whatever may be over there. And I would start by adding 16 to the other side of the equation. When I do that, it would leave me with x squared plus 6x equals 16, which is the part that I really am concerned about solving. So when I take this equation, I've got x squared plus 6x is equal to 16. I would do complete the square. So I can see my b value is 6 this time. 6 divided by 2 would be 3. I would then take my 3 and square it. 3 squared would be 9, leaving me with plus 9 plus 9. I would simplify my equation, which would leave me with x squared plus 6x plus 9 is equal to 16 plus 9, or 25. I will factor the left side of my equation, which would be x plus 3 squared, because remember, whatever this number is divided by 2 is what will go in this blank, is equal to 25. However, this time I'm not solving it. I'm not solving the equation. After I've completed the square, I'm just going to move everything to the left side of the equation so it's back together. Subtract 25, and that will leave me with x plus 3 squared minus 25. This would be my equation in vertex form. The vertex would be located at -3, -25. Because remember, whatever value is inside the parentheses, we must change the sign. We'll go back over that in just a moment. Our second problem is set up a little bit differently, and it's a little bit more complex because we actually have a leading coefficient this time of a +2. So the first thing that we have to do is, like on the factoring packet, we have to factor out the 2 from only the left side of the equation. When I factor the 2 out of the equation, it would leave me with x squared plus 2x is equal to 19. My next step is I would focus primarily on my parentheses, and I need to complete the square. So I'd take 2, my b value of 2, divided by 2, which would be 1. 1 squared would be 1. So I'm going to put plus 1 on each side of the parentheses, or on each side of the equal sign. But wait, is this really 1? So what we need to do is I'm going to actually take the left side of the equation and I'm going to do some scratch work. The scratch work is going to be very, very important for what we are getting ready to do. So what I'm going to do is on the scratch work, on the side work, I would have 2 times x squared plus 2x plus 1. I'm going to actually distribute the 2 back into the equation. So 2 times x squared would be 2x squared. 2 times 2x would be 4x. 2 times 1 would be 2. So how does this compare to the original of 2x squared plus 4x? We can see that this is actually the new term. If we distribute the value, is actually a 2. So what that will tell me to do is, instead of plus 1 here, I will have to do plus 2. I will now finish completing the square. So I have 2 parentheses x squared plus 2x plus 1 is now equal to 19 plus 2, which would be 21. I will do factor the left side, which would be x plus, and then 2 divided by 2 would be 1 squared. And then I'm going to go ahead and move the 21 back over to the other side of the equation, leaving me with 2 parentheses x plus 1 squared minus 21. And my vertex would be at -1, -21. Part 3, quadratic formula. Quadratic formula is a very, very simple tool if you are stuck and you cannot factor or you cannot complete the square. The only drawback to it is it takes a lot more simplifying than previous problems. So the big thing to remember is we're going to use this formula if we have ax squared plus bx plus c, and that is equal to 0. Will not work if the equation is not equal to 0. So I'm going to take my equation. I'm going to see that a matches up with 4, b matches up with -5, and c matches up with 6. Whenever we start, we always want to start with the discriminant part, which is the b squared minus 4 times a times c. Remember, whenever we have a value that needs to be substituted in, we will always use parentheses. So that would be -5 squared minus 4 times 6, or positive 25. And then 4 times 4 would be 16 times 6. Would be 25 minus 96. Or a -71. So now that I have this part completed, I will substitute that for the b squared minus 4ac part of the equation. So I have a negative of b plus and minus the square root all over 2 times the a value. So my b value was negative 5, my a value was positive 4, and b squared minus 4ac was equal to negative 71. So when I go to work this problem out, I have two negatives here, would make a positive 5. 71, I don't really have any factors for, so I'm going to need to leave that alone. However, we do have a negative, which means we replace that with a letter I. Over 2 times 4 would be 8. So we look at the constants, 5 and 8. They don't reduce any for that part of the fraction, so this would be our final answer. Second problem over quadratic formula would be x squared minus 8x plus 16. So we'd set it up the exact same way, where we look at doing b squared minus 4 times a times c. So b, in this case, would be the negative 8 minus 4 times our a value, but there's no value in front of x, so it's going to default to a 1, and our c value would be 16. We evaluate this, negative 8 squared would be 64, 4 times 1 times 16 would be 64, which would leave us with 0. So now that I have that set up, I'm going to substitute the values into the quadratic formula from up above. So I have a negative of my b value, which was negative 8. b squared minus 4ac I've worked out and received 0. And in the denominator I have 2 times a value, which was 1. Negative and negative 8 make a positive 8. Now square root of 0 is 0. I cannot add 0 to a number, so that my numerator would only be an 8. My denominator, I have 2 times 1 would be 2. 8 divided by 2 would leave me with 4. So I only received one answer on this problem, and that's quadratic formula. Okay, complex numbers. Remember, you always want to combine like terms. You combine real numbers with other real numbers, and you combine complex numbers with other complex numbers. Remember, I squared is negative 1. If you divide with a complex number, you do so by rationalizing the denominator. And we do that by multiplying by a smart 1, I over I. So on this first example, we have 8 plus 7i plus 6 minus 4i. So my first part I would do is 8 plus 6, or 14. My second part, I have positive 7i plus negative 4i. So 7 minus 4 would be 3i. So my answer would be, and that's a positive 3i, so I'd have 14 plus 3i. My second problem, I'm multiplying. I have 5 plus 6i times 4 minus 3i. It looks kind of like a factored equation. So I'm going to multiply the equation where I have 5 plus 6i, 4 minus 3i. So in the upper left, I have 4 times 5 would be 20. In the bottom left, I have negative 3i times 5 would be negative 15i. In the upper right, I have 4 times 6i would be 24i. And in the bottom right, I have 6 times negative 3 would be negative 18. I times I would be I squared. But we mentioned that I squared would be replaced with a negative 1. So this is really negative 18 times negative 1, or a positive 18. So when I set this up, I have like terms on diagonals. So I have 20 plus 18 would be 38. I have negative 15i plus 24i would be equal to a positive 9i. So my answer would be 38 plus 9i. My last problem, I have a division. So I need to multiply by my smart 1 of I divided by I. So in the numerator, 3 times I would be 3i. In the denominator, I have 2 times I squared because I have I times I. Now we said I squared needs to be replaced with a negative 1. So this answer would be 3i over a negative 2.